Alright everybody, topic for this video coming up is scale drawings and scale, section 6.2 in our book. So, let's get started right away. So scale drawings. What is a scale drawing? Well, it's a drawing that is the same shape as the object that it represents. Simply put, that's what a scale drawing is. Some examples. Well, one example we have is a blueprint, which is just a drawing of a larger thing. Could be a building, could be anything like that. We have maps. Maps are a scaled down version of what the Earth looks like in a given place. If we made it life-size, that would be kind of inconvenient and pointless. So those are some examples of scale drawings that we have. What does the scale of the drawing tell us? It tells us the ratio of the scale length to the actual length between the scale drawing and our actual object. So, this idea of scale is really important when we're coming up with scale drawings, and it's a ratio. So, what that means is, if we set up proportions, we can use scales to help us figure out missing lengths of things. So that is part of why they're so useful. So basically what we're doing is we're turning a real model into a scale drawing, or it could be vice versa. It could be the other way too. So on your note sheet we have an example, and it says, you are making a scale model of your bedroom. If the actual width of the room is 12 feet and your paper is 8 inches wide, what is a reasonable scale? What would each inch on your paper represent in actual feet in the room? So, to create the scale, all we have to do is set up a ratio. So again, remember, this is scale length over actual length. Let's say that we want our 1 inch for the scale. Well, if we want to figure out what each foot is per inch, what we're going to do is we're going to set up the 12 feet over 8 inches. When we do this division, we're going to figure out how many feet we have per 1 inch. And if you do 12 divided by 8, you're going to get the number 1.5. So we have 1.5 feet per inch. So technically speaking, our scale then is 1 inch over 1.5 feet. The only reason I switched it around is because, remember, in a scale, the scale length usually comes first. So 1 inch for every 1.5 feet. The reason I have feet on top in the calculation of it is because I wanted to find out how many feet we had for each inch. So 1 inch to 1.5 feet. So, first part of the problem after finding the scale says, using your scale, if your actual bed is 54 inches by 75 inches, what would the dimensions be on your scale model? Well, we can use our scale to help us here. 1 inch to 1.5 feet. So, starting out, we have our 54 inches. Let's start there. Let's figure out what that would be. Our 54-inch bed, what would that be on our actual drawing that we're making. So, you'll notice that for the actual size, our units are in feet, but right now we have this in inches. One really nice solution is we could change our 54 inches into a number of feet to make it fit our situation. If we have 54 inches and we want to turn it into feet, all we have to do is divide the inches by 12 to get the number of feet. 54 divided by 12 is 4.5 feet. So our bed is 4.5 feet in one of the dimensions. So that's going to match up better with our 1.5 feet down here. So 1 inch on our drawing to 1.5 feet in real life equals an unknown number of inches in our drawing for our bed, which is 4.5 feet long. Now we just use cross multiplication. 1 inch times 4.5 feet gives us 4.5 equals 1.5x. Divide both sides by 1.5. And that gives us x equals 3. And we know our unit from that equation over there is 3 inches. So what our scale allowed us to do is it allowed us to figure out that our bed is going to be 3 inches on our drawing if it was 4.5 feet long in real life. And to be honest, we can do a very, very similar thing for our second one. It says you try this one, and you can, if you want to try it out on your own, just try solving it first, and then start playing the video again. I would stop it right now if you want to do that. Okay, so moving on to solving 75 inches. Remember, first thing feet for this example, because actual size and our scale factor is in feet. 75 divided by 12 is 6.5. So we're going to have 1 inch over 1.5 feet equals an unknown number of inches over 6.25 feet. So what this sets up then as is 6.25 equals 1.5x. And here, all we have to do is divide 6.25 by 1.5, which ends up being 4.16 repeating. So what that tells us not feet though. Since we were making our scale, this is going to be 4.16 inches. So we know that our bed, which was 6.25 feet probably long, is going to be 4.16 inches long on our scale drawing. So that's the second example, or sorry, that's the first thing, the first example on there. Use your scale. If your actual bed is 54 inches by 75 inches, what would the dimensions be on the scale model? They would be 3 inches by 4.16 inches. Now that was only that second question. We still haven't even done anything with the bottom one, which we're going to do next. So let's say that we want to go from the scale drawing to the actual length. It's going to be a very similar process. What we're going to do is we're going to start out with our scale factor again. But this time we're told that the dresser is 2 inches on the drawing. So we're going to put 2 inches right here. Notice that we don't have to convert this one because the scale is already in inches, and we were given information in inches this time. So there was no conversion of anything necessary. And we're going to figure out how many feet that's going to be in real life. So cross multiplication again. 2 times 1.5 is 3 equals 1x. Well, 1x is just x. So our dresser has one dimension of 3 feet. For the 0.75 inches, we're going to do something very similar. 1 inch for every 1.5 feet equals 0.75 inches over an unknown number of feet. So, as you kind of saw last time, here we're going to again have x equals, but now we have to calculate what 1.5 times 0.75 is. And if you do that calculation, I would highly recommend a calculator for this. 1.5 times 0.75 is 1.125. So 1.125 feet. So our dimensions of our dresser are 1.125 feet by 3 feet. And we calculated all this using scale factors. Well, that's really it for what I wanted to give you for the notes. Your assignment for this one is to work on the back. You're going to need a ruler for this part back here because you're going to be making a scale based on this map of Wisconsin that we have here. First thing you're going to do is you're going to make the scale. Second thing is you're going to use your scale to find some distances. And the fourth one is kind of going to take you further. and use a rate with distances that you find in problem 3. So, good luck. See you at the next video.